Questions? Okay, let's apply this in a problem to see how this works. So can you please give me the limit of a linear function? Find a linear function for me.
X plus 6.
Okay, let's say 3x minus 6.
Okay.
X approaches whatever you want.
Infinity.
Oh no, that's not
okay.
gonna work.
We'll do 18.
Keep it lower.
I wanted to make a 0. Okay.
No, you don't have to be 0. Let's say 2. Okay. Let's say 3. And the answer is?
3.
Good. So this is equivalent to saying, for every epsilon greater than 0, I will find a delta greater than 0, such that 0 less than, you have to follow the rule. The rule is right here.
X minus 6.
No, this is not the function.
X
Yes,
minus 3.
very good. Less than delta. As long as I pick x close enough to 3, this will always imply, no,
3x minus 6.
3x minus 6. Yes, very good. Must be,
Less than epsilon.
I hope it's not greater than, it cannot be greater than, yes, less than epsilon. So the distance between the function value and the limit has to be within epsilon. So one more time, let's say this one more time, and then we'll prove it. So the limit is indeed 3, or saying this is equivalent to saying this. Saying this is equivalent to saying this. So for every epsilon positive, there exists a delta positive such that the distance between x and 3, in other words, I pick an x close to 3, delta close, not more than delta, then it's guaranteed that the distance between the function value and the limit will definitely have to be within epsilon, away from the limit, or the distance should be less than epsilon.
Do you get to choose which version you use?
Oh, you can use the plain English version if you want to. That's fine. But once you just write this, you're not going to have any difficulty. Just write it twice and you'll have no problem.
I don't know the problem, but I was
Good.
just referring to the limit version or the full write down.
Yeah.
No. Okay, very good question. No. This is what we are trying to prove. So both of them have to be presented. So you cannot separate these two from each other. You must write this equivalent to this. You cannot separate this from this. So here's how we prove it. Ready? Good. We start from the end. So in step 1, we find delta. That's step 1. In step 2, we show that delta from part 1 works. So in step 1, we will find the delta. Ready? Good. So we have to start from the end. That's our starting point. So the absolute value of 3x minus,
9.
good, is less than epsilon. Now I would like to factor out a 3 because epsilon is given.
3x
For
minus
I
3.
have to show that for every epsilon, delta exists. So it's 3 in parentheses.
X minus 3.
There is a property of the absolute value that allows us to separate it. So the absolute value of A times B is the same with the absolute value of A multiplied by the absolute value of B. So let's do that here. I cannot move 3 outside without stating this property. I'm not allowed to. The absolute value is not a grouping symbol. So the absolute value of 3 multiplied by the absolute value of x minus 3 is less than epsilon. How much is the absolute value of 3?
3.
Times the absolute value of x minus 3 is less than epsilon. So therefore, the absolute value of x minus 3 is less than.
Epsilon.
So I started here, and I got this. So then what is delta?
Epsilon.
Very good. Indeed. So if you say epsilon is 0.1, what will I give you delta to be? Over 3. If you say, okay, epsilon is 0.5, for epsilon 0.5, which delta will you find? Divided by 3. And this process can continue forever for any tiny epsilon as small as you wanted it to be. Will I always be able to give you a delta back?
Yes.
Because a limit exists. I'm sorry? So now I have to show in step 2, and I'm happy if you just write this. Show that delta equals epsilon over 3 works by reversing the steps from above. So all I have to do is say, okay, I start here now. Multiply both sides by 3. I get this. Change the absolute value of 3 into the absolute value of 3. Then change this into this. They change this into this, and then change this into this. So present the function and the limit less than epsilon. So instead, I'll make it easy on you, and I just want you to write as the second step, show that delta equals epsilon over 3 works by reversing the steps from above. And I'm happy with that. And I think we should work on another problem. So let's pick a problem from page 117.
So basically, like doing the derivative and doing the anti-derivative.
No, not at all.
Pause. Okay, never mind. I didn't say anything.
Good. So let's look at the numerical example first. Let's say problem 2 on page 116. And then choose another proof to look at. So in problem 2 on page 116, because I would like you to see at least one numerical example. We are given a function, and I'm copying the graph. 3 here, and 2 here. Use the given graph of f to find a number delta such that if, let me copy that part, 0 less than the absolute value of x minus 3 less than delta, then the absolute value of f of x minus 2 less than 0.5. So we are told that we are given, since epsilon is how much? Right? What is this point here?
2.5.
Very good. What is this point here?
1.5.
Very good. And we are given 2.6, and we are given 3.8. We're not given the function, but we're given the graph. And we are given those points. So we are told, in other words, what is the limit as x approaches 3 from either side? 2. Very good. And epsilon is 0.5, and we can see that. And through the function, which we are not even given, we have 2.6, and for f of 2.5, we have 3.8. And now the question is, how do I determine the corresponding delta? So epsilon equals 0.5. They're asking us to find the corresponding delta for epsilon equals 0.5. What is this? Of course, my graph is not perfect. Forgive me. So what does this equal to?
0.8.
Good. What does this equal to?
0.4.
I have to choose the smallest of the two. The interval has to be symmetric, and I have to choose the smallest of the two. And let me explain why I have to choose the smallest of the two. Assuming I make the mistake and I choose 0.8. So then this is 0.8. 3 minus 0.8 will be 2.2, right?
And that goes out of the range.
Exactly. So it goes out of the, and if I choose an x here, look what happens. Will the x be close enough to the limit? It will be wider than epsilon. So in this case then, I know how much delta should be. Can anyone tell us what should delta be? 0.4. It cannot be 0.8. Any questions? Sure. So this is the limit. This is a given epsilon, which is 0.5. We are given in the graph, we are given 2.6, and we are given 3.8, and we are given the limit and x. In other words, a, I should say. So, as I mentioned a long time ago when we started this, we have to choose the smallest distance between a and this end and a and this end. So since the distance between 3 and 3.8 is 0.8 and the distance between 3 and 2.6 is 0.4, I have to choose the smallest distance. But my graph is not exact, so the best graph is in the book.
And that's the answer.
And that's the answer. We were asked to find
Right.
delta.
I literally just have to pick out the smallest.
Yes. Yes, because otherwise you could find an x that will not make the mechanism work.
See that's easy.
Good. Good. That's exactly what we did, but that's exactly what we did, but without numbers. That's exactly what we did.
I like that.
Good. Good. I'm happy. I'm happy. Good. So let's do then number 3, since you understand this very well. Before we do another algebraic problem. So use a given graph of f of x, which is the square root of x, to find a number. Say it again.
It's 8:15. Or it's
I'll stick
8:16.
around for all the
Yeah.
problem.
Okay.